Hey everyone, this is a moving shadow problem. A ball is dropped from a height of 20 meters, but it's happening 12 meters away from the top of a 20-meter lamppost. The ball's shadow caused by the light at the rope of the lamppost is moving along ground level. How fast is the shadow moving 1 second after the ball is released? So here's kind of like your shadow from this light here. So this light's coming out here. And we have similar triangles here. We have this triangle, the big triangle is the green one, and the little triangle is this one right here. So we're going to use similar triangles, and we also are given the equations. So the first thing we want to do is take a derivative of y with respect to t. Now this is going to be squared too. And so this is going to equal negative 9.8t. Alright? If you just take the derivative of that. Now, when we do y sub 1, I'm going to write this equation on the next slide. When we do y sub t equals negative 4.9 t squared plus 20. So at 1, we have negative 4.9 plus 20, which gives us 15.1 for 1 second for the original. And then for the derivative, when we plug in 1, we just get negative 9.8. Now, so that's just information we need to know. Now, by similar triangles, and I'm going back to this, we're doing 20 is to x as y is to x minus 12. Because this whole thing is x, and you have to subtract the 12. So by similar triangles, we're going to get 20 is to x as y is to x minus 12. So it's 12 short of that. And then solving by cross multiplying, you get 20x minus 240 equals xy. Alright, and then we'll plug in when y is 15.1, this one, we're going to get 20x minus 240 equals x times 15.1. So basically we have 20x minus 15.1x equals 240. And factor out the x. And divide both sides by that, and you're going to get x equals 240 over 4.9. Whoops. Well, I didn't save room, so let me erase that and move it up here. So x equals 240 over 4.9. Now let's go back to our equation, and we have 20x minus 240 equals xy. And let's take the derivative, and we're going to get 20 times the derivative of x with respect to t, this goes away, equals x times your derivative of y plus y times your derivative of x with respect to t. Alright, so when we solve for derivative of x, we're going to get, let's see, let's put the derivative of x's together. So we're 20 derivative of x with 20 derivative of t minus y times derivative of x with respect to t equals x times the derivative of y with respect to t. Now factor out the derivative of x with respect to t, and we get 20 minus y equals x times derivative of y with respect to t. So derivative of x with respect to t equals x over 20 minus y times the derivative of y with respect to t. Alright, then at this point we're going to do it t equals 1. So when we have t equals 1, we're going to plug everything in. So we get derivative of x with respect to t equals x we already found out was 240 over 4.9 and then we had 20 minus y, and my y was 15.1. We found that, and then we're going to multiply that by negative 9.8, which is your derivative of y with respect to t. And then when you plug that in, you get approximately negative 97.96 meters per second. And that's all. Thank you. Have a nice day. Bye-bye.